So in the last video, we talked about what to do, how to find an ionic compound between two simple elements. Something like if I had, better pen, there we go, okay. Magnesium ion and a nitride ion. And we talked about how we could take these numbers, move them down to their corners and be left with an Mg3 and an N2. And that works. And the system, the process is going to continue to work through this new thing. But not all of our ions are what we call monatomic ions, which means you can just pull a symbol off the periodic table. We also have this thing called polyatomic ions. If you look at the word, poly, it means many or multiple. Okay, atomic means that I've got atoms, so I'm going to have many atoms in these ions. Basically what they are, for the most part, are covalent compounds that have somehow gained or lost some electrons. You'll notice most of them have gained. Most of them are negative ions, except for this ammonium up here. Okay. We have to be able to use these things too, because a lot of the compounds that we'll have to work with have these ions in them. Okay, so a couple of things. We need to make sure that these things stay together as a group. This phosphate down here, what it means is I have a capital P, that stands for phosphorus, and then a capital O, and that stands for oxygen, followed by this 4. I have 1 phosphorus atom and 4 oxygen atoms. And collectively, as a molecule, they have gained 3 extra electrons. So this thing, it comes as a group, and it has to stay together. So if I had, instead of magnesium nitride, I had magnesium, it will work, okay, magnesium phosphate. I'm still going to have that Mg2+, but now I write my phosphate ion, PO4 3. Minus. Well, if I just bring this 2 over here to be beside the 4, then I'm going to end up with like a 42 right here. And that's not at all what I wanted to, it's not at all what we wanted to see. So before we can do anything else, I'll do this in blue, we have to like wrap our polyatomic ions kind of in bubble wrap. We have to kind of close them in. Now you're going to leave this charge out here because, like, once again, I have phosphorus and 4 oxygen atoms that have gained 3 extra electrons. They have a 3- charge. Okay, so I'm going to take then, after I wrap it up, I'm going to take the 3 and move it just like we did before down here to the magnesium. I'm going to take the 2 and I'm going to move it over here to our phosphorus. And that is going to leave me, we'll just do it in the pencils, with an Mg3 parenthesis PO4 close 2. Okay, we'll do another one somewhat similar to that. So again, if I had something that said, oh, I don't want sodium. Let's go with aluminum. Chlorates. Okay. Well, I know that the formula for an aluminum ion is Al3+, and I see this ATE right here. That ATE is a huge red flag that says I'm going to need this polyatomic ion list. Okay, so I check my list for anything, right? Remember that this word says ammonium and not aluminum. It's easy to miss, okay? And we check here and we can see that the word carbonate, sorry, try that again. We can, did I put the chloride on here? I apologize. Carbonate. Okay, so you can see that the word carbonate is right here, exactly like we have it written. So we're just going to write exactly what it says here. A capital C, capital O, 3 on the bottom, with a 2 minus. And again, that tells me that I have a carbon, 3 oxygen atoms that have all together gained 2 extra electrons. Okay, we're going to use the other color. Wrap it in our parentheses, pick up our oxidation numbers and move them over. Okay, and we'll be left with an Al with a 2, parenthesis, CO3, close 3, like that. Okay, now a couple of other little minor things that have to be done and we've got to keep an eye out for. If I had something that said, say, sodium sulfate, again, sodium is a metal. Metals are always just write the symbol Na plus. Okay, this ATE, when it ends in an ATE, it's going to come off of this list. So I come up here, sulfate is a capital S, capital O, 4's down here, 2's up there. S, O, 4, 2, minus. So I can take my colors, wrap them. Remember, I've got an invisible 1 here, and it's going to go over there. I've got a 2 here, and it's going to come into here. Now, right now, I have Na2, SO, 4, close parenthesis, and then an invisible 1. Well, I don't need, up here, I needed the parentheses because there was a number out here that I needed to multiply through. Well, there's not a number out here anymore. So we're going to rewrite it one more time, but without the parentheses. Na2, SO, 4. If there's nothing down here, you don't still need the parentheses. Okay, I want to do a couple more examples, just to some things that commonly easily get missed. Okay, if I had, let's say, calcium hydroxide, okay, my calcium is a metal, so Ca2 plus hydroxide. Even though it ends in that IDE, it's on our list, so we got to make sure we pull it, right, is right here, OH minus. Okay, now a lot of times kids will go, well, there's no number here, so I don't need parentheses. That's not what makes us need parentheses. We need parentheses because there is an oxygen and a hydrogen that go together. Okay, and together they have this -1 charge. So you still need parentheses around your hydroxide, and our cyanide up here has the same basic problem where there's no number, so kids think they don't need the parentheses, but you do. So we're going to put the parentheses there, take this 2, move it over here, the invisible 1 goes there, and we end up with the Ca invisible 1, parenthesis OH, close 2. Now you see how if I didn't have the parentheses, it would suggest that there's only 2 hydrogens. There's really 2 hydrogens and 2 oxygens. I have 2 of these OH groups. Okay, and the last thing, actually 2 more. 1, if I say I have a couple more, aluminum sulfide. Kids get so caught up sometimes in using these that they don't check. IDE here, this sulf here ends in an ATE. We are not going to use this. This is like we've done them before, and they're going to be an Al3 plus S2 minus, and we'll cross there and get an Al2 S3. Okay, so watch out for those. Okay, next, if I had a tin, that's a V, for, let's say, chromate. Okay, this is an SN4 plus, that's what that IV means. Chrome ATE means it's got to come up from up here. Okay, it's right there. CrO4, 2 minus. Put our things in parentheses. Well, before we can cross, remember, we have to watch out for our oxidation numbers and see, we want a lowest ratio, right? Is 4 to 2 a lowest ratio? No, it is not. So we will have to reduce that ratio to 2 and 1. Okay? So we'll take the 1 to here and the 2 to there. And our final answer is going to be SN, invisible 1, CrO4, and then a 2. Okay? Really, it doesn't throw all that much more at us. This process is the same as the binary ones. The binary just meant that there were two elements, right? Like this, there's an aluminum and a sulfur. Okay, nothing else. These ones are the polyatomic. All you have to do is make sure you put it in parentheses before you cross. Okay, and then if you get to the end and you don't need the parentheses anymore, there's nothing out here, then you take the parentheses back. Okay, good luck.